boys and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary, and thank you guys for tuning in with me. Well, my favorite students in the whole universe, we have made it to the end of our journey. You guys have been most spectacular. Today's lesson will be a combination of reviewing all of the content that we've learned, and regardless of our journey ending, you guys need to keep practicing your basic knowledge of fractions. When in doubt, fraction strips out, and we have learned ways to draw pictures to help us better understand the size of the fractions. Without further ado, let's get back into our lesson. So in today's lesson, we will be ordering fractions from least to greatest and from greatest to least. And what that simply means is to put them in order from biggest to smallest and smallest to biggest. So we want to go ahead and begin by reviewing each of the fractions, and we want to talk about how many of those fractions are necessary to create a whole, and how many of those fractions are equal to half, greater than half, and less than half. So the royal blue strip is our whole. Then we have our halves. The halves are two parts, and you need both parts to get the length of the whole. So 2 halves is equivalent to 1. And let's see what this looks like. It looks like 2 halves is equal to 1. Then we move down to the yellow strips, which are thirds. If you take a whole and you partition or part it into 3 equal-sized parts, you will get the size of 1 of a third. You need all 3 of those parts to get the whole back. Fractions are nothing more than taking a whole, breaking it into parts, and putting it back together. Sometimes you can do that with multiple wholes, and you'll get an improper fraction, because you'll get a whole bunch of pieces of a size. And when you put all those pieces back together, you get all the wholes that you broke up in the first place. Moving on to the fourths. How many fourths do we need to create a whole? You need 4. If you take a whole and you break it into 4 equal-sized parts, like a puzzle, in order to get that whole that you started with, you need to get all 4 of those pieces and put them back together. Moving on to the 6. How many 6 do you need to make a whole? You need 6 sixths. So 6 sixths is equivalent to 1 whole. What about your eighths? 8 eighths is equivalent to a whole. Boys and girls, it's basically however many pieces you have, you need all of those pieces to put back together to create that whole. So if it's 12ths, you need 12 12ths to make a whole. If it's 16ths, you need 16 16ths to make up your whole. Let's examine one of these fractions. Let's take a look at the 12 12ths. We know that we have parts of a fraction like the numerator and the denominator. And we have the fraction bar. Each fraction has 3 parts. The fraction bar is the line separating the top number from the bottom number. The bottom number is called the denominator. The denominator serves a special purpose, and it gives us certain information. It tells me, that bottom number right there tells me how many equal-sized parts you broke the whole into. If that whole was a candy bar, that denominator tells me you broke that candy bar into 12 equal-sized parts. Maybe you broke it into thirds, broke the thirds in half, and then broke the 6 in halves. Either way, you came up with 12 equal-sized parts. If you made a circle, you broke the circle into thirds, parted each of the thirds in half, creating 6, and then you parted each of those 6 in halves, creating 12. That's what the denominator tells me. It tells me how many equal-sized parts the whole has been broken apart into. The numerator, which is the top part of the fraction, tells me how many of those parts you are describing. You're describing 12 of them. Sometimes fractions are described using the term shaded or unshaded. So if I said 12 12ths have been shaded, shade the fraction to show 12 12ths. Then I would shade in 12 of those 12 parts, meaning I would shade all of those parts, which also means I would shade the whole thing. If this number was a smaller number, like maybe 4/12, then I would shade 4. Sometimes a question might be asked about the unshaded portion of a fraction, meaning not shaded. If it says circle the parts of the fraction that are not shaded, then I would circle 4 of the 12ths. 1/12, 2/12, 3/12, 4/12. Because in this example, it's referring to the unshaded portion. So just a little information about numerators and denominators. Denominators refer to how many equal-sized parts the whole has been broken into. The numerator refers to the part of the fraction that you're describing, whether it's unshaded or shaded. Okay, let's move into half. We know that this is considered half. Half can be used as a benchmark. What that means is you can use it as a middle meeting ground, kind of like a tool for measuring fractions. Because most fractions have a halfway mark. When you look at the fourths, half of 4 is 2. So 2 of the fourths will match the size of half, and you can even take your fourths and bring them out here just to double check. 2/4 is equivalent to half. Now, you do have some fractions that you can't use enough of them to match the size of half. Do you remember which fraction strip you can't match it with half? Because you can get one of them up there, but by the time you get the second one up there, it's already greater than the size of the half. Do you remember which fraction that one was? The third. If you put 1/3 up here, it's actually smaller in size than a half. So when you try to join in another third size piece, wah, 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 you've already created a train that's longer than the half. So we concluded in our last lesson that 2/3 was greater than half. What about just one of those thirds? 1/3 is less than half. 2/3 is greater than half, but one of those thirds is less than half. Why is 1/3 less than half? Because 1/3 size piece is smaller in size smaller in length than the half piece. So, we're not going to use the thirds because we know that some of them are less than half and some of them are greater than half. So let's go back to the fourths. Now let's move in and add the 6. Do you remember how many 6 will match the size of a half train? There's 6 of them. How many of the pieces do I need to match the size of a half? Only half of the 6, which is 3. So we know that 3/6 is equivalent to half. What about the eighths? Do you remember how many eighths are equal in size to a half? 4. 4/8 is equivalent to half. What about the 12ths? Do you remember how many 12 size pieces are equivalent to half? One 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s. Well, there's 12 12s. You would need half of those to make the size of a half. Half of 12 is 6. And what about the 16ths? Do you remember how many 16ths it will take to match the equal size of a half? Let's count them. 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, 7/16, 8/16. It takes 8/16 to match the size of a half. So here we know that we do have some fractions that are equal to half, and we have some fractions that are greater than half. I'm going to throw the third in at the bottom, because now we're going to focus on, let's do what would be less than half. So we know that 1/3 is less in size than half. Well, if it takes 2/4 to match the equal size of half, what would happen if I removed one of those 4th size pieces? Do I still have a train that's equivalent to half? No, I don't. So if 2/4 is equal to the size of half, less than 2/4 is also going to be less than half. What about the 6? I need 3/6 to match the size of half. Excuse me. What if I don't have 3 and I have 2? If 3/6 is equal to half and I have a number of 6 that's less than 3/6, like maybe 2/6, then I have an amount of 6 that's also less than half. Let's try the eighths. I need 4/8 to match the equivalent size of half. Well, what if I don't have 4/8 and I only have 3/8? Is that still going to be equal to half? No, it's not. Because if I need 4/8 to match the size of a half, and I have less than 4/8, then I'm going to get less than half, because I don't even have enough to make a half size. What about the 12ths? I need 6/12 to make the size of a half. What if I don't have 6/12? What if I only have 5/12? Is 5/12 going to be equal to the size of half? No, it's not, because you don't have enough yet. You need 6 to make half, and you only have 5. So you actually have an amount that's less than what you need for half. So 5/12 is less than 6/12. And it's also less than half. The 16ths. I need 8/16 to match the size of a half. But what if I don't have 8/16? What if I only have 7? Or 6/16, or 5, or 3? Am I still going to have enough for half? No, I won't. If I need 8 for half, and I'm looking at a fraction that's less than 8/16, then that fraction is not enough for half. In fact, it's too small in number and in size. So it's also less than half. So here we know that, excuse me, you need some fractions, you need a certain number of each fraction to make half. When you don't have enough for half, you're looking at a fraction that's less than half. Now let's go back and review. If I need 2/4 to make half, some of these I'll have to slide over. What happens when I have more than 2 of the fourths? I'm more than what I need for half. So if I get more than 2/4, I have actually greater than half. If I have less than the 2/4, I have less than half. But if I get more than 2/4, I have greater than half. 3/4 is actually it's actually more than or greater than half. I was going to say longer, because the train is longer. Look at the train for half. It's the same length as 2/4. A 3/4 is longer. Let's take a look at the 6. I know that 3/6 is equivalent to half. Just 3 of them. I know if I don't have 3, I don't have enough to make the size of half. I'd actually have less than half. But what happens when I have more than 3/6? Look at this train. It's longer than the 2/4, which is the same as the half. It's longer than the half train. So 4/6 is greater than half because it's more than 3/6. And 3/6 is equivalent to half. I have more than the amount of 6 that I need to match the same size as the half. So I have more than half. Let's take a look at the eighths. I know that 4/8 is equivalent to half. It's the same size and length as half. What happens if I have more than 4? Because I know what happens when I don't have enough to get 4. Then I'm looking at a train that's going to be smaller than or less than my half train. I'm going to be looking at a fraction that's less than half. What if I get 5/8? if I only need 4 to match the equal size of a half, what if I get more than 4? Then I'm going to create a train that's going to be longer than half. 5/8 is greater than half because it's greater than 4/8. And 4/8 is the same as half. So let's take a few minutes to reflect. Whenever you're looking at fractions and you have more than what you need for half, you're looking at more, or you're looking at a longer train. 5/8 is greater than half. 5/8 is greater than 4/8. And 4/8 is the same as half. So then 5/8 is also greater than half because I have more than what I need to make half. Let's continue the pattern, and we're going to make a rule. Let's take a look at the 12ths. Do you remember how many 12ths we need to match the size of a half? Let's count the train. 1 12, 2 12s, 3 12s, 4 12s, 5 12s, 6 12s. 6 12s are greater than what I need for half. To match the train of half. 6 12s are equivalent to half. I'm talking faster than I'm thinking. So what if I have 7 12s? Look at how much space 7 12s come out as compared to half. Half is all the way back here. 7 12s, let's just draw a better line. 7 12s comes out all the way out here. There's still some missing space here. A 7 12 train is longer than a half train. Therefore, it's greater. 7 12s is more than what I need for half, which is 6 12s. 7 12s is greater than 6 12s. Therefore, 7 12s is also greater than half because 6 12s is equivalent to half. Let's take a look at the 16ths. Do you remember how many 16ths I need to make half to match the size of a half train? Let's count them. 1 16th, 2 16ths, 3 16ths, 4 16ths, 5 16ths, 6 16ths, 7 16ths, 8 16ths. 8 16ths is equivalent to half. Well, what if I have one more 16th? Do I still have an amount that's equivalent to half? Or do I have an amount that's now greater than half? Look how much 9 16ths stick out further than half. And all the other fractions that are equivalent to half. 9 16ths is greater than 8 16ths. And if 8 16ths is equal to half, 9 16ths are greater than half. Are you getting this? Of course you are. Last but not least, we know that 2/3 is greater than half. Because the thirds were the only fraction that we took a look at in these lessons that you couldn't get to match the size of a half without splitting it into 6. So now we're going to practice. We're going to use the knowledge that we just got, and we're going to practice putting fractions in order. We're going to practice ordering these fractions from least to greatest. That means from the smallest in size to the largest in size. Are you ready? Of course you are. If you feel a little unsure, take out your fraction strips. Draw a picture. Okie doke. So let's take a look at the first set of fractions that are up to bat. We have 13 12s, 6 6, And I want to compare these fractions to half. I want to put these fractions in order from least to greatest. So let's take a look at 13/12. Let's come over here. I'm going to put these over here. And look at our 12s. Let's count them. 1 12, 2 12, 3 12, 4 12, 5 12, 6 12, 7 12, 8 12, 9 12, 10 12, 11 12, 12 12. In each whole, I only get 12 12s. Well, how would it look adding 13 12s in there? How do you even get 13 12s? Here's my 1/2. Well, in order to get 13 12s, you're going to need an additional 12. So what does that tell me about 13 12s? If I need 12 12s to make one whole, and I'm using 13 12s, well, that tells me that 13 12s is going to be greater than one whole. Look at how much 13 12s stand out of all of my fraction strips that are equal to one whole. In fact, 13 12s is an improper fraction, and it's equivalent to one whole and 1 12. That's a pretty large amount. Let's take a look at 6 6. So 13 12s comes out to right here. Let's take a look at 6 6. 1 6, 2 6, 3 6, 4 6, 5 6, 6 6. 6 6 is the same length as my whole. 13 12s comes out to here, and 6 6 is the same length as the one whole. At this point, if we're comparing 13 wholes to 6 6, which is longer in the train? The 13 12s or the 6 6? The 13 12s are greater in length. So as of right now, 13 12s is greater than 6, because 13 12s is also equivalent to one whole and 1 12, and 6 6 is equivalent to just 1. 13 12s has an additional piece than the 6 6. They both have 1 in it, but the 13 12s has an extra piece. Okay, now we need to take a look at the last fraction, which is half. Half is all the way over here. Half doesn't even make it out to the 6 6, and it doesn't make it out to the 1 12. So if I had to put these in order from least to greatest, least meaning the smallest, which is the smallest of the three fractions? Half. Which would come next? 6 6. And which would come last? 13 12s. Now I can write these fractions by putting a comma in between them to show that I'm ordering them from least to greatest, or I can use the comparison symbols. I'd start with half, and I note that half is less than. Look at the great less than symbol. The gator's mouth is facing away from the half because he knows the next fraction is going to be larger than the half. Therefore, the half is less than this fraction. 1/2 is less than 6 6. Is that true? Yes, it is. The next symbol, we're going to go ahead and put 13 12s here. Which symbol should we use? Should we use the less than symbol, or should we use the greater than symbol? Think about which way the mouth opens in the symbol. Did we say 6 6 was greater than 13 12s? Because we know 6 6 is equivalent to one whole. But we know 13 12s is equivalent to one whole and 1 12. So would you rather have one whole cookie or one whole cookie and a piece of another cookie. You'd rather have 1 and 1/12 or 13/12. So the greater than symbol doesn't open up to the 6/6. The gator doesn't want to eat 6/6 because he knows 6/6 is equivalent to 1. We're going to use the less than symbol with the gator's back turned to 6/6, but his mouth is open to 13/12. I'll read this comparison statement twice, and you can read along with me the second time. Here we go. 1/2 is less than 6/6 is less than 13/12. Now let's read it together. 1/2 is less than 6/6 is less than 13/12. Excellent job. We're going to compare we're going to order and compare one more set of fractions, but this time we're going to order them from greatest to least. Now, it's very, very, very important that you guys pay attention to those words, because sometimes you'll be asked to order fractions from smallest to biggest, pretty much, and sometimes you'll be asked to order fractions from biggest to smallest. So pay attention to those words. And I dropped my eraser, but I'm getting it now. Okay, so let's take a look at the next set of fractions. We have 4/16, 9/12, and 3/8. Now, a common misconception that I see kids making when they're trying to put fractions in order from greatest to least. They look at the numbers and they'll say, well, this one has 16 at the bottom, and then this one has 12, and this one has 8. And because 16 is larger than 12, and 12 is larger than 8, then this must be the correct order. They will use the denominators to figure out which is the correct way to order them from least to greatest. Or they will use the numerators, and they'll put them in order by the numerators. Well, both of those are incorrect. We don't order fractions by the numerators and denominators unless the denominators are the same. We order fractions by looking at their size. We draw pictures, we use manipulatives to find out which is which. So let's take a look at 9/12. 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12. 9/12 comes out to about here. And let's take a look at 4/16. 1/16, 2/16, 3/16, 4/16. 4/16 come out at about here. It's kind of like I'm making a number line. Now let's take a look at 3/8. 1/8, 2/8, 3/8. 3/8 come out at about here. Now if I was to look at this as a number line from 0 to 1, the closer you are to 1, the larger you are. The farther away that you are from 1, the smaller you are. So if I'm going from greatest to least, which of these three fractions is closest to 1? The 9/12. And going backwards, I would run into the 3/8, and then finally the 4/16. So from greatest to least, I will put them in this order. 9/12 is greater than 3/8 is greater than 4/16. I'll read it one more time and you guys will read it with me. 9/12 is greater than 3/8 is greater than 4/16. You guys are fabulous. Thank you guys for working your hardest and never giving up. I am super duper proud of you. Keep up the excellent work. It has been my pleasure working with you guys, and I'll see you next time.